recording now. Good afternoon, all. We'll be continuing on the topic of string today, strings in C. And yesterday there was a question regarding the fgetS. Actually, it wasn't a question, but we were trying to do a simple example with this. And we saw that the example was not working as I explained it would work. And the reason for that is actually I have misread the definition here. And I was trying to explain that definition in an example. So fgetS actually works very similar to getS, except that it will actually read as many as, let's say, whatever you enter here. And then afterwards, it will also return the line. If you have a line, like in this case, for example, here, it will return this line, but different than getS, it will have an end of line character at the very end of the string. So the string, the returning string for this guy will have, this is an example till the, let's say, till the point here, the dot, and then it will have a new line character. And of course, it will have also the null character indicating the end of the string. So this was the misinterpretation yesterday. So be aware that fgetS will actually read a line, but it will return the end of line character at the very end. And you have to handle that properly in your coding if you want to do something with that. All right. So let's continue where we left yesterday. We talked about quite a bit. We discussed various methods of sorting an array of strings. And we had, if you recall, an array of strings. We can define an array of strings in this fashion here. So you'll see here that I have strings of 5 strings. And each string has at most 10 characters, excluding, of course, the last one, the null character. And we said, how can we actually sort this if you want to sort this? And I have shown you 2 different ways of sorting. One was actually sorting and manipulating the original string. So the original string was, let's say, when it was this way. Someone has their microphone on, please mute it. It's actually confusing my sound here. So if this is my original string, the first way of doing was we actually reshape the string such that it will have the right ordered strings. There is still someone with mic on. Please turn your mic off. And this, in this case, if I am actually sorting this in the, let's say, ascending order, I will have Daisy here, right? And I'll have perhaps, which one is that? Yeah, Marigold. And then Petunia, right? And then Rose, and then Tulip. This will be one way of sorting it. And we said this sorting, if you recall the code that we discussed, which I put on our website at Moodle in the lectures folder, you can see it there, the code that we wrote yesterday together. In that code, we would actually do a few copying of strings from one place to another place. For example, if we were doing a simple, let's say, a sort starting from this one and finding the, let's say, starting with the first one and finding the entry that needs to go there, meaning the smallest entry, and it will be Daisy. So it will actually probably do this one first, a copy between these, a swap between these, and then Marigold is going to be there. P and R is okay, and then there will be another swap with this guy. To get Daisy up there, we'll do 2 swaps that will be copying 10 characters or up to 10 characters each time, which is, and it is going to be doing this 3 times, copying it to a temporary string, copying it back to overriding the first string with the second string, and then copying the temporary string back to the first string. So the second string, there will be 3 copies, right? So in that case, I can, we said this is perhaps inefficient. And that guy is still not actually turning his microphone off, so I'll do that myself. Let's see, whatever that is. Whose mic is on? I don't see anyone's mic on. And yet I can hear someone. All right, I don't know who I'm hearing. Maybe you need to turn off your videos as well. Please do so. Okay, anyway, so we said this is perhaps not efficient. And another possibility was actually using an array index to this guy. And we could actually sort the indices instead of the original array, original list of characters or the array of strings itself, right? Right. Someone has their microphone on. Please turn it off. Please mute your microphones. I can hear someone breathing even, okay? This is a little bit distracting. All right. So we said, and I have given that code to you as well, and we wrote it together. We used an integer index, and that index an array of indices. And we said originally it will be the same size as this guy. So there will be original list will be 1, 2, 0, 1, 2, 3, 4, meaning this is the order. And when we order this properly, using just this one, not the original string array, we would actually get the proper order of this particular indices by Daisy is going to be the first one, right? And then Marigold is going to be the second one, PQR, and perhaps 2, 3, and 0, for example, maybe something like that. So by just actually manipulating this index array, I could actually avoid copying these large strings back and forth when I need to swap them. All right. So what I will do now is, okay, there is another possibility that we could do. And in this case, what we'll do is we'll use instead of an array, index array, like an integer array, we'll be actually doing a pointer array of pointers. So we can actually define an array of pointers like this guy here, right? This is an array of pointers. So this is a pointer here. It's an array of pointers. What type of an array? What is the type? The type is actually a character, and with the string having the particular string having 5 entries, or the particular this is gonna be actually each of these is gonna be each of these gonna be a pointer, and they are gonna be pointer to a specific array of characters. Therefore, it's gonna be a character pointer, a character address, and I'll have 5 of them. Now, pictorially, you see that actually this alpha P will have the addresses of each of these strings in my original string or array string. or array of strings, right? So how would we actually initialize this one? This is very simple. Alpha P, for example, alpha P, the first entry of alpha P, this one, the 0th entry, would point to the address of the first entry in my array. My array is this guy, the string array is this guy. The first entry is going to be the original, right? Original, the 0th entry. That's it. This is actually another way of getting the address of the string in this array. This says I have an array of 5 here, and each of these array, each of the entry is actually having a string of at most 10 characters, right? Therefore, I can access to each of these strings by using the variable name for that two-dimensional array, and then using the first the row index, the first index would actually give me the address of that particular thing. So I could actually now get the address of this thing by just using an ampersand sign here. So this way, I will actually say, okay, original 0 is this guy, and I want to get the address of this guy, this one. So either I would say I could do it this way, original 0 and 0, and address of it, or just the original 0 here. So this way I can actually now create a list of addresses that is actually pointing to each of these strings in turn. And then I would do my simple sorting on this part. I will sort this such that this will actually show me the sorted list, sorted strings. So let's see how that code looks like. I will show you the code for that one. I have prepared another deck of slides for this. So this is the code that will do this one. This is, I have 10 entries, sorry, here. Let's do this one. So I have 10 entries, 10 character long strings, and each, I have 5 of them at most. And this is the particular double two-dimensional array that will keep this string of array of strings. So here I have 5 strings, and each of them will have at most 10 characters. And this is one way of actually initializing such a thing. And I have a code here. I'm going to go through this code that actually does the sorting of this flowers array by using array index or array of pointers pointing to individual entries of these. And when I run this one, this particular code, what I did is I actually created, and so let's go back to here. I created this guy here. This is my array of pointers. I will have 5 of them, and each of them is going to be a character pointer, meaning an address of an array, of a start, or of a position, place where a character array is actually residing in the memory, right? And what I do here is, in this line of code, I am actually initializing that to be, for each of these entries here, will actually point to each of these strings. I have an array of strings, which has 5 strings in it, and each string has at most 10 characters. And I am actually taking the address of the first string for when I is 0 and putting that address in my array of pointers, pointers into the first entry. Okay. And then here, what I am doing is I'm actually now printing this thing by just actually here I'm gonna be printing two things. This index I, index is now a pointer to index 0 points to this guy, right? And index, let's say 2 points to this guy. And when I print this in two forms, one is in string form here, then it will actually, since it points to the place in the memory where that, this is 3, of course, here. No, this is 1, 2, 2, it must be 2. So this is 2. So when I actually send this to printf with a percent sign s, it will actually try to read that memory place as if it is actually a string, meaning it holds characters, and at the somewhere of in the sequence of characters starting from that location on, I would have an string terminator character, which is a null character. When I actually do it this way, when I print the same thing with percent sign X, capital X, it will print me the address of that specific place. When I actually do it with this one, it will print the content of that place. If whatever that address is pointing at, I would get the array of characters starting from that position and on till I reach end of string character, a null character, right? So this is a real run of this code. You see here is that you have the address, and each address has, you can see that this is 1, 2, 3, 4 bytes. So this guy has 4-byte address space. So 32-bit address space. And the first one, they are this, since this tulip, marigold, petunia, and these 5 strings are one after another, we will see that the first one is actually starting at A0. And then since this will have, in principle, TULIP as the readable characters in that string, and there is a null character here, and then since I defined them to be length 10 in this particular case, then I will have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 things remaining here, which is actually not important to me. So I don't know what they have. They have something. For marigold is going to be the similar story, and for petunia is going to be the similar story. And you can see that the next address for marigold will start 10 bytes after the first address. Why? Because we have 10 bytes for the first string maximum, not less than 10 bytes, even though the word tulip has only 5 characters. I am storing the 5-character string in a 10-character array, right? This is how we actually define it here. This is what the definition tells me, that I will get for each string a 10-character long array. And then I can actually store any word in that character array, which is less than 10 characters long. So 9 or less number of characters in that word can be kept here. So let's actually do this again with a abstract memory managed by the showing some sort of an abstract memory here. This is make-believe. This is not going to be exactly like this. It's going to be something like this. It has to be something like this. But I don't want to deal with these complex numbers here. Not complex, but complicated numbers here. Instead, I'm assuming that when I actually do this at runtime, this line of code, assuming that it's actually, it will give me a pointer. Actually, it will take, it will create a memory in memory some blocks of, it will reserve some blocks of memory. How many bytes in the memory? Each string will have 10 characters at most, so 10 characters there, 10 bytes, and then I have up to 5 of these. So I have 5 times 10 characters. So each of them is bytes, so 50 bytes. Assume that this block, the flowers, when it is actually allocated this way, it will be a continuous chunk of memory for 50 bytes. And the first row, the first 10 bytes will actually host the first character, string in that array. Second 10 characters will host the second string and so forth. I'm sorry, I changed this number here just to make sure that it is easier to do. So instead of 10 characters, I'm going to be showing you here 8 characters. So 8 characters per string, 5 strings, it will be 40 characters. Assume that each of these blocks here hosts 4 bytes. So that means that each of my string, this 8-byte string, will actually occupy 2 blocks here, right? So there are 2 blocks, each of them is 4 bytes. So in total, I have a block of 8 bytes, which will be sufficient to keep one of these entries. All right, and I have 5 of them. So this is the first block, this is the second block, the third block, and the fourth block, and fifth block. You can see how it is actually represented inside it. You see that tulip will not fit into the first block alone, because first block, in this case here, this part, will have only, we can only hold 4 bytes. Tulip has 5 bytes, so the first 4 characters will be in the first block. The second 5 characters, or in this case, there is only 1 character left, it will be placed in the second block for these 2 blocks here, 10-byte long blocks, or 8-byte long blocks, right? So marigold is going to be the same. MARI will be in the first part of that 8-byte block, and GLD will be in the second part. And petunia is going to be the same. The first PUTU is going to be in the first part of the 4 bytes, and NIA will be in the second part. And rose will fit into the first block. The second block in this case is not used, except that actually there is a use. There is one use. There is the end of string character, the null character is there. And for Daisy, first 4 bytes will include the DAIS, and the second block will only hold the Y character and then end of string character, right? So this is good. So we have now, when we do this initialization, this part of the thing, this is how my memory is going to look like. So my memory has this part of my memory, which is 40 bytes, and these 40 bytes, starting from 0008 till 48, will be occupied by my flowers array. This 5 strings, and each string has at most 8 characters in them. Okay. Now, when I look at the second one is actually another array, but now this time this array is actually a pointer array, meaning individual entries of this array is gonna be holding a pointer. Assuming that my address space is 4 bytes, then I would have actually hold in this thing here, starting from this location, and there are 5 of them, 1, 2, 3, 4, 5 of them. I will have these 5 blocks. Each 4 bytes of this block will actually hold an address. Now, this is the definition. What type of an address is that? I am assuming that that address, because I define it to be this way, that address is a character address, meaning whatever this is going to point at, this will point at somewhere, something later on. So let's see. Then this will actually point at something, and what this is telling C is telling me that, or I'm telling C that this address that I'm gonna be pointing at, the cell that this thing is gonna hold, will hold a character array, an array of characters. All right, this is good. Then I have this one. T is a character, again, a pointer. So it will hold actually a single address, which is 4 bytes. But the type of the address that I have here, I know, and this is gonna be a character. So wherever this points at, for example, it can point at here because there is a character here in the beginning. But for example, it may not be able to point this one. This may not be a character entry or character entry. All right. So this is what this is telling me. All right. And then I have these regular INJs. These are my variables, classic variables. They are not pointers. And I am assuming that they are here. One of them is here, the other one is here. So now let's go to this line of code where I initialize my index array of pointers. This index is an array of pointers to point each of them, each entry here, the first entry, 0th entry, first, second, third, and fourth entry, to first entry one I want to point at here, the second entry I want to point here, the third entry I want to point here, the fourth entry is rows, and the fifth entry is this one. This is what I want you to do. Right? So for that, I have a counting loop here. I have 5 of these things, and what I will do is I will take the index I, the first one, and I will just simply take the address of flowers I, the first entry in the flower array of flower names, right? So when I do this one here, what it does is actually, let's look at this one. It says index 0, this is 0, I is 0 right now, is flowers 0. What is flowers 0? Flowers 0 is this address here, which is this guy. This is 008. Just I put 8 here, 008 here, all right? In the second iteration, when it is 1, this is 1. So in the flowers 1 is here, which is this address. I'm just going to put this address here, and so forth. Therefore, I will actually fill this in after these 5 iterations. Right? Now you can see that index, so this is index 0, and this is index 4, and 1, 2, 3 in the middle. So index 4 has an address, which is 40. 40 is actually pointing to beginning of this word daisy, whereas index 2 is 24, and 24 is actually pointing to the word that is petunia, the first character of that P character. All right. So now you see that this index is an array of pointers. And now I know another thing about this one is that because I define it to be a character array, character pointer, I know that it's a pointer, array of pointers of type character. This is very good. Now, what I'm going to do is now using this one, I'm going to print out my array or my array of strings. So how does it happen? It will be very simple. I'm going to do another iteration. I starts from 0. You can see here. And when I come here in the second iteration, this one is going to be index 0. And this one is going to be index 0. You can see that index 0 is what? Index 0 is 0008. When I print this using this guy, it says, take that value and print it as a hexadecimal value. So it will be whatever the 008 is going to be, 008. The hexadecimal correspondence to that one is going to be 008, right? The second one says, take this address, this is an address, and starting in that address location, assume that there is a string and print that string for me. So this is what it is saying. This is saying that whatever address I'm sending you, it is supposed to be pointing to a string. Okay. Is there a string at this address? Yes. You can see that the first 008, the first byte of this address is holding a T character, character T. The second one is U. The third one is L. The fourth one is I, and so forth. And then the fifth one is a P, which is continuing, right? And then the sixth one here is indeed a null character, which tells me that now my array actually of characters ended, which is a string in itself. So what this first iteration will do is it will actually take this thing and print out. So you can see here, the first one is printing the content of this guy as a value. The second one here, printing, assuming that this is an address of a character array, and assuming that that character array starting from that location will have at some point in its sequence a null character, then I will print it. This is what it is saying. In the second iteration, what will happen is that, of course, I'll have the same thing. In the second iteration, this is going to be 1. Now I'm going to be looking at this guy here for here. So this will say, okay, print 0016. In hexadecimal, this will be 00F, right? And then this one says the same thing. Take this 0016 as an address and assume that it is actually a character array which has an ending in itself somewhere in it as a null character, and print it till that null character is actually reached. And do this for 2, then 3, then 4, and done. So at this time, what will happen is that I will be actually getting something like this that we have seen here. Something like here. This will be this part of the thing, or this part. I have 2 of these things here. So the address and the string that relies in that address, starting from that address location. The address here and the string that lies in that place. How do I know that it's a string? Because I assume that that address is a character array, and I know that this guy is a character array because of my definition here. And then the second assumption is a little bit of a kind of a trust issue, trust thing. I trust that, or since I am kind of thinking that this is a string, I'm going to assume that there is going to be a null character in the boundary of that array, wherever that is. And I can interpret it as a string. That second part is just trust, just a kind of a implicit understanding between compiler and the programmer that there is indeed a character, a null character somewhere in the bounds of that particular array. And this has been the case from the beginning. This assumption was always in our assumption list, that we would actually adhere to it. We will follow it up. Otherwise, things will break down. And compiler is not going to be responsible for that breakdown. You will be responsible as a programmer if you don't actually, if you violate that assumption. All right. So now what we did is we actually printed this guy. Now here, after printing, now I will actually sort these guys. So, but what I'm gonna do is I'm gonna do the sorting, not here, but I'm gonna sort these entries. So can someone tell me, after the sorting, what I should have in this one, for example, here? Can anyone tell me what I should have instead of 0008 in this pointer array? Someone tell me, please. What will we have? I'm trying to see your answers in meeting chat. Are you all sleeping? So if the thing is correctly running, meaning I will actually, I'm assuming that my code here is correct, and I want to actually do an ascending order of this text. So if this is the ascending order of this text, then what will be here at the end? Is this going to stay the same or is it going to change? So right now it says 008. 008 is saying that tulip is the first word that I want to actually have in my sorted list. Is that correct? If not, then what do we do? What's going on, people? We have about 91 people and no one is answering. Say it is something wrong or right. I'm not gonna punish anyone by saying something wrong or whatever.
Hocam sizin chatinize gelmiyor mesajlar.
How come? So you are actually sending me something and I'm not seeing it?
Evet hocam.
Okay. How is it so? All right. So where is my meeting? Let's look at this guy again. Let me see here. And this guy is not showing anything. And did you see my message in this thing or no?
Gelmedi hocam.
No. All right. This is strange. I can see this thing here. So I think you are all here, but I cannot see this one, huh? Microsoft Teams. Okay, tell me anyway, someone, what will be the thing? Just turn on your mic and tell me. If this sorting is correct, what would I have here after the sorting? What address should I have here? 00, the first two is 00. So the sorting means I should actually point for the first one here. I should point to Daisy, not Rose, because Rose comes after Daisy, not Petunia, because Petunia comes after Daisy, or not Marigold or Tulip. So what is the address of Daisy? Come on, people. Someone tell me.
0040.
40, yes. Because this is where I want to have. What will be the second one? Second one is going to be what comes after Daisy, right? After Daisy, probably what will come is Marigold. So it's not going to change. The third one, after Marigold, it's going to be Petunia, I guess. So it's not going to change. And then after Petunia, it will be Rose. It's in the right place, not going to change. And then the last one is going to be, of course, Tulip. Tulip has an address of 0008. So this will be what I would have at the end of this code block. If it does it right, this is what I should see, right? Okay, let's look at it, how it works very quickly. So I start from I0, and then I go to here. It says J is 1 plus I, which is 0 plus 1 is 1. Okay, so I is 0 and J is 1. So it says here now it comes here. So I is less than number of flowers and j is less than number of flowers. So I can get into the third if block. And if block says, do a string comparison on index I. What is index I? Index I is index 0. Index 0 is having this address. Where does this address points to? This guy here, this word tulip. Index 1, where does it point to? It is 0.016. And this one points to this guy, marigold. So when I actually say string compare index I and index j, I am saying string compare the string on address 008 versus the string on address 0016. Okay. And when I look at these, one of them is tulip, the other one is marigold. Is tulip less than marigold? No. So this will actually give me a positive response. Since it is a positive response, it is bigger than 0, then I will need to do a swap of these two things. I'll do the swap. So what does the swap means? Swap says, take the index I, which is 0008, put it in a temporary variable, t. Again, the t is here character address. It's a character pointer, all right? So now t has 0008, okay? And then it says, okay, take this guy here. So t has now, I am at this line here. Now this guy says, take index j, which is 0016, put it in index I, which is 008. So what will happen here is that now if you see, this is gonna be t is gonna be 0008. This is gonna be overwritten by 0016. All right. And then this line will say, take t, which is 0008, put it in index j, which is 0016. Now overwrite this guy with 0008. Now you can see that I did an ordering by looking at indices or this array pointer. I see that this is partially ordered now, meaning in this case, marigold comes before tulip. So this will, if I print this one, so if I do the same thing here, this code, what am I gonna get out at this place here? It's gonna be outputting something like this: 0.016, sorry, and this is gonna be marigold, and then 0.008. It's gonna be tulip, and 0.024 is gonna be petunia, and 0.032 is gonna be rose, and 0.040 is gonna be daisy. So after this first iteration, I got an update on my list, and now marigold and actually tulip changed places. Remember here, or notice that I haven't done any change on my original array. My string array is the same. What I am doing is I'm just manipulating the ordering of the addresses for each of these things, right? If I do it another time, so if I do this multiple times, or the second time, let's say, let's do this in a second time. So now I have here 0016. This is the first iteration. This is 008, right? Now this is 0, and this is 2. This is the second iteration on this guy. So j is 2 now, j increased 1. Now I'm comparing string compare index I. Index 0 is what? 0016. What is in 0016? Marigold. I'm comparing marigold versus what? Index j. Index j is 2, which is 0024, this is index J. 0024. 0024 has the word pattern, right? Now, can we compare these? Yes. When I compare them, this will give me an answer. String compare Petunia will actually give me a negative number because Marigold comes earlier in the dictionary list than Petunia. Therefore, I am not gonna touch this. I'm gonna go one forward. Okay. So if I go one forward, what will happen is, again, let's do one more time here. Now this is still gonna be 0, right? I is still 0. What will happen to J? J is gonna be 2 now. So if J is 2, what am I doing here? Let's look at this one. So I is pointing to 16. You can see that I is pointing to, and J is pointing to this guy, J2. Did I do it wrong? No, J has to be 3, sorry, because it was 2, now 3. So J is pointing to 0032. So when I come here in this if, it's gonna compare index 0, which is, what is it? Index 0 is pointing to, index 0 is 0016. 0016 is Marigold. Still, it is comparing Marigold to what? Index J. Index J is 3. 3 is actually this guy, 0032. And 0032 has rows in it. I'm comparing Marigold versus rows. And Marigold is still less than rows. Okay. Then I will move one forward. I'm not going to do any swaps. I will go one forward. And then at the end of this thing, so this is what is going to happen. Then now I'm going to go to the fourth one because I'm going to increase J by 1 again. So now it is 4. And after 4, it's going to actually stop this inner loop and go back to the outer loop. Now let's look at this guy. Index 0 is still Marigold. This guy is Marigold, right? And index J is index 4. Index 4 is 40, and 40 has Daisy, right? Now Marigold is not less than Daisy. Therefore, I'm going to go here and do another swap, right? This time what I'm going to do is this swap is going to actually do this way. So now I am swapping. If you can see here, no, I shouldn't have done this one. Okay, anyway, let's put this back in place. So before the swap, I had 0016 here, 0008 here, and I am swapping this guy with this guy here. So at the end of this thing, what will happen is that this guy is going to be replaced by 0016, and this guy is going to be replaced by 0040. Now you can see that I have a new ordering of this list after the first inner complete inner iteration is done, or for loop is done. So what happened is that now in this particular thing, I have 40, 8, 24, 32, and 16. If I print this one, what do I see? 40 is Daisy, right? 8 is Tulip, and 24 is Petunia, and 32 is Rose, and for the last one is 16. 16 is Marigold. Now I have a list, new list, partially ordered list, where the first one is the least entry, the smallest entry, which is Daisy, and the rest of the thing is kind of mixed up. I have to actually do another iteration to now sort this part of the array. Okay, any questions? And I am not 100% sure why am I not seeing this thing here. Okay. Any questions? You can ask through your audio. No questions. Okay. So if I do this a few times, that I'm gonna see is that actually this is gonna be filling this in proper order. Like starting from here, it will go and it will change it. And then when I come here, it will have this order, which is the right order. 40 is Daisy, it should be the first. 16 is Marigold, it should be second. 24 is Petunia, it should be third. And 32 is Rose, it should be fourth. And 08 is Tulip, it should be the fifth entry. All right, questions? If there are no questions, let's take a 10-minute break, and we'll. In the meantime, I will try to sort out what this problem is, and you can take a break for 10 minutes. We'll be here exactly at 2:29. All right. Okay. I hope it is doing the recording.